The purpose of this section is to familiarize you with how to solve for force, mass, and acceleration. In the last chapter, we studied velocity and acceleration. If an object changes its velocity, it accelerates. A negative acceleration is deceleration or slowing down. How do we cause this acceleration? We must apply a force. A force is simply any push or pull. Looking at a few force diagrams, we see that there are a lot of forces acting on any object. On an airplane, we have the weight force acting in the negative y direction, and we have lift acting in the positive y direction, a drag force acting in the negative x direction, and thrust from the engines acting in the positive x direction. On Earth, the force of gravity holds things to the ground. On a car, we have the weight force of a car acting in the negative y direction, a reaction force from the tires acting in the positive y direction, friction and air resistance acting in the negative x direction, and the driving force from the engine acting in the positive x direction. Before we talk about force, we have to discuss a little about Sir Isaac Newton, who was one of the greatest scientists and mathematicians that ever lived. He was born in England in 1643, and while he was in college, he had new ideas about motion, which he called his 3 laws of motion. He also had ideas about gravity, the diffraction of light, and other forces. He noticed that an apple on a tree has no speed, but upon falling to the ground, it does have a speed. He concluded that a force must have acted on this apple to cause the acceleration. Like we discussed in the previous chapter, in order to have an acceleration, there must be some force acting on the object. Newton's contributions to the understanding of force and motion are so significant that the SI or metric unit for force is named in his honor. This unit of force is called the Newton, abbreviated with a capital N. Let's take a look at Newton's laws of motion. His first law of motion states that a body at rest will remain at rest unless acted on by an outside force. A body that is in motion will continue in motion with the same speed and in a straight line unless an outside force acts upon it. This is sometimes called the law of inertia. As an example, the crankshaft, transmission, and drive wheels of a vehicle will not propel a car forward from a rest position unless a significant force is applied to the piston to rotate the crankshaft. Newton's second law of motion states that the force acting on a body is equal to its mass multiplied by its acceleration. The greater the force that is applied, the more acceleration the object has. As an example, since trucks are more massive than cars, they need a larger engine to provide more force to accelerate the truck. Let's take a look at the main formula we will be using in this section. Force equals mass multiplied by acceleration, or F equals ma. Our equation circle has force on the top and mass and acceleration on the bottom. We can also look at the unit circles for this formula. In the English system, force is measured in pounds, abbreviated lb, mass is measured in slugs, and acceleration is measured in feet per second squared, just like before. In the metric or SI system, force is measured in newtons, abbreviated N, mass is measured in kilograms, abbreviated kg, and acceleration, like before, is measured in meters per second squared. Let's take a closer look at these force units so we can get a better feel of what they mean. A pound in the English system is like a pound or 4 sticks of butter. A newton in the metric system is like an apple. We will be using the conversion 1 pound is equal to 4.45 newtons quite a bit in this section. Looking at the mass units, a slug weighs about 32.2 pounds, and a kilogram weighs approximately 2.2 pounds. Note that both of these approximate weight measures are on Earth. We will talk more about how the weight of objects vary on different planets in a later section. In the next video, we will look at some examples of how to calculate force, mass, and acceleration.